Hello everyone, I welcome you all to our YouTube channel Nirja Education, and if you have not subscribed our channel yet, please do it quickly. Today we are going to see lesson number 2, polynomials, and in that we are going to discuss zeros of a polynomial. My dear children, this is very easy as well as very important topic for you, because on the basis of these things you are going to discover more thing in your standard 10. So it is very necessary for us to be clear about this topic. But before moving towards it, let's see value of polynomials. How to find the values of polynomials if value of variable is given. As you can see, here I have listed 3 examples over here. Let's see first. Here it is given p of x is equal to 5x square minus 3x plus 7 at x is equal to 1. That means we are going to replace x as 1 in this polynomial. So let's do it. P of x, we need to replace x as 1. So we can write p of 1 instead of p of x is equal to 5x square, that means 1 square minus 3x, x into 1 plus 7. Let's solve it further. 1 square is 1 and 5 into 1 is equal to 5 minus 3 plus 7. 5 minus 3 is equal to 2. 2 plus 7 is equal to 9. Let's see another example. P of y is equal to 3y cube minus 4y plus under root 11 at y is equal to 2. We are going to replace y as 2 in this polynomial. So in place of p of y, we can write as p of 2 is equal to 3 2 cube minus 4 into 2 plus under root 11. Let's solve it further. 2 cube is equal to 8 and 8 multiplied by 3 is equal to 24. 24 minus 4 to the 8 plus under root 11, and 24 minus 8 is equal to 16 plus under root 11. So this is the value of p of y at y is equal to 2. Now let's see last one. P of t is equal to 4t raised to 4 minus 3t square plus 70 minus 2. We need to find the value of this polynomial at t is equal to a. That means we are going to replace t with a. Let's do. P of a is equal to 4 a raised to 4 minus 3 a square plus 7 into a minus 2. So my dear student, this way you can find the value of polynomials if value of variables are given. Just now we have seen how to find the values of polynomial. As you can see, here I have written one polynomial. P of x is equal to x minus 5. What we are going to do is, we are going to take different values of x and then we are going to find different values of p of x. Let's start. First I am going to take x is equal to 2. Now let's find p of 2 by putting 2 in this p of x. 2 minus 5. 2 minus 5 is equal to minus 3. Now let's take x is equal to 4. Then p of 4 is equal to 4 minus 5, which is minus 1. Now I am going to take x is equal to 5. Then let's put p of 5 is equal to 5 minus 5 is equal to 0. So we can call phi is zeros of this polynomial. Why? Because for the value of x is equal to 5, we are getting our polynomial p of x is equal to 0. Hence we can call phi as 0 of this polynomial. In general, if we are going to say what is 0 of polynomial, then we say that a 0 of polynomial p of x is a number c such that p of c is equal to 0. This means to say like that, if we are going to take any number c and for that number c our p of c is equal to 0, then the c we can consider as zeros of polynomial. In short, अगर कोई भी वेरिएबल की वैल्यू के लिए हमारी जो पोलिनोमियल है वो 0 मिलती है तो वो वैल्यू को, वो वेरिएबल की वैल्यू को हम zeros of polynomial कह सकते हैं. Now let's discover some other things about zeros of polynomial. As you can see, here I have listed two questions. First one is, what about zeros of constant polynomial? My dear students, if you have seen previous parts of this chapter, in that we had discussion about constant polynomial, right? -2, 5, -7, like this constant term, we can consider this as constant polynomial. Now let's take one constant polynomial over here. I am taking 5. In this constant polynomial 5 is the coefficient of x raised to 0, and this is also we had discussed in previous part. Why? Because x raised to 0 is always 1. So this 5 we can consider as coefficient of x raised to 0. Now let's take any value of x. Suppose I am taking 2. So it will be 5, 2 raised to 0, and any number raised to 0 is always 1. That means 5 into 1, and 5 into 1 is equal to 5. So as you can see, we got the answer for x is equal to 2 is 5. In fact, if we are going to write, if we are going to take any number in place of x, our answer of this polynomial will be 5 always, because it is never going to turn into 0, because x raised to 0 is always 1. So my dear students, from this we can conclude like that constant polynomial, a non-zero constant polynomial is not having any 0. That means a non-zero constant polynomial is having no 0. Our second question is, what about zeros of the 0 polynomial? This 0 we can consider as 0 polynomial. So for this, answer is zeros of the 0 polynomial can be any real number, every real number. Why? Because any real number multiplied by 0 is always 0. So in case of any real number, we are always going to get answer as 0. So we can consider every real number as a zeros of zeros polynomial. So I hope now you are having clear idea about zeros of polynomial. Now let's solve some of the example. Check whether -2 and 2 are zeros of the polynomial x plus 2. Here they have given one polynomial x plus 2, and we need to check -2 and 2 are zeros of polynomial or not. How we can check? If we are going to put the value of -2 and 2 in this polynomial, and for that value we are going to get our polynomial as 0, then anyone can be zeros of polynomial. Now let's check this. Let's write p of x. Given polynomial is x plus 2. For that, first I am going to find p of 2. That means we are going to replace x with 2. 2 plus 2 is equal to 4. And here we are not getting answer as 0. So 2 we cannot call as zeros of polynomial. Now let's check it for -2. P of -2 is equal to -2 plus 2, and -2 plus 2 is equal to 0. So here we got answer of polynomial 0 for x is equal to -2. So we can call -2 as a zero of polynomial. So my dear student, this way by putting the value of given variable, you can check either the given values are zeros of polynomial or not. Now let's see different kind of example. Find a zero of the polynomial p of x is equal to 2x plus 1. Here one polynomial p of x is equal to 2x plus 1 is given, and we need to find zero of this polynomial. Right? How we can find the zero of this polynomial? So by solving this equation, we can find zero of polynomial. Let's take p of x is equal to 2x plus 1. P of x, suppose p of x is equal to 0, then 2x plus 1 is equal to 0. If we are going to solve it further, 2x is equal to minus 1, and if we are going to find the value of x, then x is equal to minus 1 by 2. So this is the 0 of polynomial. How to verify? By putting the value of x in this polynomial. You can verify either we got our answer right or wrong. If for x is equal to minus 1 by 2, this polynomial is going to turn into 0, then our sum is right. This is how we can solve the example and we can find the 0 of polynomial. But instead doing this, let us derive a general form how to find the 0 of linear equation, so that by putting that equation we are able to find our 0. We don't need to solve the equation every time. Now let us see how to do that. Now we are going to derive general form of how to find zeros of linear polynomial. If you have seen previous parts of this chapter, in that we had discussion about 3 kinds of polynomial on the basis of degree: linear polynomial, quadratic polynomial and cubic polynomial. If we are going to talk about linear polynomial, polynomial which all are having degree as 1, that polynomial we can call as linear polynomial. Now let us take one linear polynomial, p of x is equal to ax plus b, where a not equal to 0. This is a standard form of linear polynomial which is having degree as 1. Now let us solve it further. Ax plus b is equal to 0. If I am going to take this b, this side it will be minus b, x is equal to minus b upon a. And here we got how to find 0 of any polynomial. It is minus b upon a. So my dear students, as you have seen, here we got only one 0 of linear polynomial. So from this we can also conclude like that linear polynomials are having only and only one 0. So whenever examples are given to find the 0 of linear polynomial, you need to do is you need to compare that polynomial with ax plus b, then you will be getting the value of a and b, and by putting this equation you all are able to find the 0 of linear equation. About zeros of quadratic and cubic polynomial you are going to study in higher classes. For now only how to find zeros of linear polynomial is there in your syllabus. Now let us see some of the example on the basis of this. Find the 0 of polynomial, and just now we have seen how to find the 0 of linear polynomial. So now let us use that concept over here and solve some of the example. First one is p of x is equal to x plus 5. Let us compare this polynomial with the standard polynomial p of x is equal to ax plus b. Let us compare first term first, ax and x. So here a is equal to 1, coefficient of x is equal to 1. So we can write a is equal to 1 for this polynomial, and b is 5 over here. So now we are having the value of a and b. So by the equation minus b upon a, we are able to find the 0 of this polynomial. Minus b is equal to 5 and a is equal to 1. So minus 5 upon 1 is the 0 of this polynomial. And if you want to verify, you can put value of x is minus 5 by 1 in this and you can check. Next one is p of x is equal to 3x minus 2. Now let us again compare this polynomial with the standard linear polynomial ax plus b. Then a is equal to 3 over here and b is equal to minus 2. Let put this value in the equation minus b upon a minus 2 upon 3, minus minus will turn into plus 2 upon 3. So this here we got 0 of polynomial. So this way, by using this equation minus b upon a, you are able to find the 0 of any linear polynomial. So here we are going to end our session for today. I hope you all have understand concept as well as how to solve the example. Thank you everyone for watching me.